In this video we will have a look at an exact replication of the Netemeyer model with the 23 paths, and we will see how we can test for structural invariance using this model, and as well as assess what the outcomes of that are and see what the next steps are. So here's the model. If you don't already have labels on your paths, don't worry about that, because we will be using the multiple groups analysis function that automatically would add these labels. So in order to start testing for structural invariance, we need to click here and click OK. And this brings up a number of models. However, we are only interested in creating one additional model to the unconstrained model, and that's a model where the structural weights are constrained to be equal across groups. And for now you can ignore groups 2 through 5. We're actually going to delete them in the next step. So click OK, and you double click on model 5, and we're going to delete this. 4 goes, 3 goes, and 2 goes. In model 1 we're going to rename the structural invariance. And here we can see the constraints that are imposed, and these are constraints for all the structural paths, and there's 23 of them in total. So let's click close and let's run this, see what happens. Alright, let's bring up the output to see what we have here. Okay, so first of all we see immediately here that we have a horrible chi-square. It's very high, so the fit overall is not very good. Further, in order to compare for structural invariance, we click here on model comparison, assuming model unconstrained to be correct, and we see that the chi-square value of the difference between the invariant model and the unconstrained model is 200. And we see that these two models have a significance value of 0.000, which is significant. And that means that the difference between the unconstrained and the structurally invariant model is significant. Therefore, we cannot claim that we have structural invariance in this case. So let's see, what are the things that we can do for this? First, I think it would be helpful if we establish a model which had better fit, and there are two separate problems here. One is that we need to adjust a number of regression paths, and there are a number of negative error variances that are floating around in this model. We'll deal with each of these in turn. Let's first look at our modification indices to see what regression weights are suggested. Now here you have all the different regression weights. Here it is important to be careful. Right now we're only concerned between regression weights between latent variables. So while there are some modification indices, like down here, that are really large, these are not between latent variables. And while the modification index is large, and statistically we would improve our fit if we added this path, it would not make theoretical sense. So let's just look at the latent variables. And here we can see that we have two of these up here, which are rather high. And this is work family conflict, leading to in-role performance. And we also have family work conflict to in-role performance. And I think it makes sense theoretically that there could be linkages between these. So these are actually the only regression paths between latent variables where two modification indices are suggested. So let's add paths for those two. So I'm going to click out of this, and we're going to draw these regression paths like this. Right. And let's clean it up somewhat. Good. And let's run the model again to deal with our second issue. That's the error variances that are floating around in this model. See, you can see it already there. That's the error variance. But first, let's have a look at here. So we can see already now that the chi-square has improved dramatically. Now, if you look at the following variances are negative, we can see that we have a number of negative error variances. Now, and what is very problematic about this model is that the error variances float around if you constrain them. So I have experimented somewhat with this, and what we're going to do is that we're going to constrain two of the error variances to be equal across groups. So let's do that. So here, this one, it's called A-1, group 1, and in sample 2 it's called A-2. So we're just going to rename so they have the same name in both of these groups. And now that we rename here, this will be constrained to be equal across all our different models. We're going to do the same for E16, which is also problematic in some solutions of this. And this is going to be called B1. Now, if I switch between these groups, you can see that they now have the same name for both of these. So let's run this again. And we're just going to have a look at the chi-square value to see if that has improved. We still have some problems, but I think we'll have to accept them. Let's go here. And we can see that the chi-square value now is rather good. And in the next video, we'll now test this model for invariance.